Hello, everyone. On this occasion, I will explain about my research entitled Plagiarism on Mobile Programming Assessments, Automated Detection. I'm Oscar Karnalim. I'm from Faculty of Smart Technology and Engineering, Maranatha Christian University. So, first of all, the introduction. So, mobile applications become more popular nowadays due to the growing number of mobile users. Such number was projected to reach 7.49 billion in 2025. And there are already 8.93 million mobile applications with a total of 255 billion downloads. While there are a number of plagiarism detectors for programming, none of them are focused on mobile programming assessments. So, as the contribution, we present a plagiarism detector for mobile programming assessments. We focus on Dart, a popular programming language for mobile development with Flutter. So we have three research questions here. The first one is which disguises that are often employed for plagiarism in mobile programming assessments? Can our plagiarism detector handle those? The next one is how effective is the presented plagiarism detector for identifying copied submissions in mobile programming assessments? The third one is about the efficiency, so how efficient it is. So this is how our plagiarism detector works. So at the beginning, there will be like tokenization, and after that, content generalization and gram formation, index generation, similarity measurement, and finally, similarity reporting. So for the evaluation setting, so our dataset was collected from a mobile programming course for IT undergraduates offered at the even semester of 2022 and at the odd semester of 2023. So in the even semester, they have like 24 students, with 8 of them participated in our data collection as the disguiser. Both mid and final tests were individual assessments, and the mid test was about developing a mobile app for real-time Bitcoin value converter with the help of an API. There are 24 submissions, and for the final test, it was about developing a mobile app based on each student's case study. So there is a total of 23 submissions. For the old semester, only had like 13 students, with 7 of them participated in our data collection. So both mid and final tests were similar to those in the even semester, and the mid test only had 13 submissions, and the final test only had 11. So how we can address the first research question, disguises of copied mobile programming submissions. So we invited students enrolled in mobile programming courses to participate in our data collection. So they were asked to act like a perpetrator, plagiarizing their own mid and final test submissions. While plagiarizing, they were also asked to record their attempts of disguising the plagiarism act. Records of the participant discussing attempts will be qualitatively analyzed with a thematic analysis. For convenience, we map the disguises to a common plagiarism taxonomy. So the next one, how we can measure the effectiveness. The first one, we employed similarity degree and top K precision. Top K precision is essentially the proportion of copied submission pairs on K retrieved submissions pairs, where K is the rank position of the copied submission pair. The effectiveness was measured on a dataset resulted from addressing RQ1, where each copy submission would result in a scenario, and the copy submission will be treated as a standard submission on given assessment. Our plagiarism detector will be employed to identify the copy submission and its original among other submissions via pairwise comparisons. And the third one, for the efficiency, report the processing time in nanoseconds. And yeah, this is recorded right before our plagiarism detector is run, and it will be stopped after the plagiarism detector finishes. So now the findings. So it is about disguises of copied mobile programming submissions. So for level 0, there are like many participants do that because it is like verbatim copy, but only in some parts of the code. It could be easily identified by our plagiarism detector because there are no changes from the copied submissions. The next one is level one disguises, which is about comment and white space modification. So the copied submissions are different only in comment and white space modification. Some examples are adding comments, removing comments, reformatting code appearance, and removing blank lines. So our plagiarism detector remove comments and white space prior to comparisons, making changes in such aspects were futile. Level two, it is about identifier renaming. It is the most common disguise for the assessment. So it was performed by three-fourths of the participants, and the modification focused on various components, including variables, methods, parameters, classes, widgets, events, and files. Because our plagiarism detector generalized identifier names, so any changes would be easily detected. Level 3 disguises is component declaration relocation, so like changing directory structure, path changes, and also method reordering. Again, our plagiarism detector ignored directory structures, and it broke down the token string to shorter substrings, removing the impact of reordering attempts. Level 4 disguises is method structure change, like method parameter reordering and positional to name parameters. Our plagiarism detector generalized all parameters, so it doesn't matter. Level 6 disguises is about logic change, removing code parts for complex tasks. It is not specifically detected. About level 5 disguises, program statement replacement, there are many examples here, and they are again not specifically detected. We only deal with changing constants for text, font style, application layout, and general use. We deal with that by employing constant generalization. And now the second research question, which is the effectiveness of the plagiarism detector. So as we can see in the picture, our plagiarism detector was not able to ensure that all copy submissions would have high similarity because it does not cover level 5 and level 6 disguises. The similarity degrees of the mid-test were lower than their final test counterparts because they are shorter and not much code was left verbatim during the disguising stage. There was no interesting finding across the semesters, and some assessments had less similarity because they had more unhanded disguises. But even though they have like not 100% similarity degree, it is still result in high top K precision. So it is 100% for the final test of the even semester, and it is quite good for the mid and final test of the odd semester. But it is not really 100% because the involvement of AI generated code on there. Okay, precision for the mid test is quite low because some students oversimplify the copied submissions. The third one is like efficiency. So basically it is quite fast. It could perform 2,400 comparisons in 3 seconds and 546 comparisons in 2 seconds. So as the conclusion, we presented a plagiarism detector for mobile programming assessments, focusing on Dart programming language and Flutter development environment. While the detector does not always hide similarity on copied submissions, it is still effective on identifying copied submissions. The detector can handle many student disguises except program statement replacement and logic change. It is relatively efficient as it can process 2,400 comparisons in 3 seconds. And of course, the detector works slower on more submissions with large amount of code. For the future work, we plan to expand the plagiarism detector so that it can identify AI-generated code and to reconduct the study on larger data sets and to observe how our instructors use the detector in real classroom environments. Lastly, we develop a plagiarism detector for online code resources. Okay, that's all. Thank you. If you have any questions, you can contact me by email.